Hello and welcome to the lecture, Crustal Deformation and the Types of Faults. In this lecture, I'll be looking at the different types of faults and how you distinguish between the different types, focusing specifically on the hanging wall and the footwall. Okay, so whenever you start looking at the different types of faults, there are four different types. You have what is called a normal fault, a reverse fault, a thrust fault, and a strike slip fault. You'll notice that it's labeled right lateral strike slip here. I will just tell you how to distinguish each one, but that's the four basic types of faults: normal, reverse, thrust, and strike slip. Okay, so to distinguish between each one of these, you have to look at how does the hanging wall actually move. Okay, on three of those, that's very important. On the strike slip, it really doesn't kind of matter, and we'll look at that right there. Okay. So what you want to look at is you have to kind of know, first of all, we are talking about brittle deformation. Whenever I talk about brittle deformation, that means that the rock is actually broken when placed under stress. Whenever it does that, it creates a geologic feature known as a fault. If it has ductile or elastic deformation, that's going to give you different types of geologic structures, so we're not going to worry about those right now. Okay, so looking at each one of these, here's what you actually do. Whenever you identify the fault line, so let me grab my pen here. Okay, so first of all, you can see that we've identified our fault line right there. Now, here's what you have to remember. The hanging wall is defined as the wall or block of rock that is on the hanging side of the fault system. Okay, and so whenever you start looking at this, there's several ways that you can actually teach it, but if you look at which way the fault is actually oriented, look at the side that is slightly on top of the other side. So you can see that this block is on top of that fault. Okay, this block is on top of that fault line. This block is easily seen as being on top of the fault line. Okay, so the block that is slightly on top of the actual fault line itself is the hanging wall. And then what you want to do is you want to look at which way does the hanging wall move, because A, that's going to tell you about the type of stress that is being applied. Okay, so let's first focus on the first thing first. If the hanging wall moves down, it is actually called a normal fault. If the hanging wall moves up, it is actually called a reverse fault. Now, a thrust fault is a special type of reverse fault. Okay, so it's really a thrust fault and a reverse fault are actually kind of the same, but the primary difference is you'll see that the hanging wall is thrust on top of the actual fault system. It's on top of the fault itself, or on top of the other block of rock. Okay, and that's what we focus on there. We'll come back to right lateral strike slip here in a second. Okay, so that's what you focus on with each one of these. Okay, now to go ahead and address it now is if you look at a strike slip fault is just basically any offset. So right there's the fault. Any offset of those. And that's one of the primary things you want to look for, is you want to look at, see how the yellow and the yellow are offset horizontally? Well, that right there is the sign of a strike slip fault. Now, whenever you start saying, okay, is it right lateral or left lateral? I'm not going to focus on that in this course, but I'll show you how you come to it because you're going to see it. Imagine standing right here, you're standing on the fault, and you're looking at this block of rock. Well, which way did the rock move? It moved to your right. Okay, so you're looking that way and the block moved to the right. If you were looking this way, notice what happens. You look at the block and it still moves to the right. Okay, and so that's how you determine right lateral strike slip or left lateral strike slip. Okay, so here's what we're going to do. Is we're going to go ahead and I'm going to show you some pictures here, and then we're going to kind of walk through this. All right, number one, you have to identify the fault system. I can easily, let me go back to my drawing here. I can easily see that the fault system is right there. So there's my actual fault right through there. Okay, now I match up these two rock layers. So now I know that, okay, now I've got to determine which one is the hanging wall. Well, you can see that this side is on top of the fault, and so this side moved downwards. And so because of that, because the hanging wall dropped, this would be considered a normal fault. And to do this, what you have is you have a tensional type of stress. That means that the crust is pulling apart. And so whenever the crust pulls apart, so you have to look at everything as a whole, it's pulling apart, and the rock brittly breaks, and the hanging wall side will drop. So this is what is called tensional stress. Okay, and so that right there, so by looking at this geologic structure, we can deduce what type of stresses were associated with this landscape, and then of course you get a geologic structure to tell you what that stress was. And so the geologic structure we have here is of course a normal fault. So let's look at the next one. What we can do here, now this one's going to be very unique, is because what we see here is I notice that I have two fault systems right there. Okay, so now I have two fault systems going on right here, and now I'm going to match a layer of rock, and the one that I can easily see is right there, and then the third one is not so easy to pick up. It is, I gotta find a different layer because it looks like this one went up. Okay, so that's what we're looking at there. This is a very unique structure here. So this one's a little bit more challenging. So we'll take off and we'll knock off this side. Let's go ahead and focus on this side right here. Okay, so what you're seeing here is you can say like, okay, I've got those two right there. And then what ends up happening is, oh no, I see it right now, right there. There is the matching layer. Okay, so yes, this one is there. Okay, so what we see is we know this part, we can see here, it's on top of this fault. So then you say, okay, the hanging wall moved down. So this is a normal fault. And then what you see over here is this rock layer matches up with this rock layer up here. And so what happens is you get the downward motion again. So we have two normal faults. And then what we end up seeing here is we have two normal faults where this section through here did all the dropping, and so it makes these sections look like they went up. So here is your hanging wall. Okay, it dropped down, and then on the outside you actually have where the rock appears to have moved up. We're not focusing on that, but you focus on the hanging wall. Okay, so we have normal fault, two of them here in this case, and then what you end up having is you have tensional stress again. And then as a result, this thing, because this is the part that dropped, okay, what you end up doing, let me erase this for you here so that you can actually see a good diagram of it, because we have two normal faults. So now we know that. We know that we have two normal faults right through this area. Normal fault, normal fault. This one moved down. This one moved up. And so what you end up with is you end up with a block of rock that looks something like that. Well, the part that goes down is called the graben. The part that goes up is called the horst. So this is a special type of feature known as a Horst and Graben. Okay, they kind of go together. Horst and Grabens go together. And so that's what you have in this one. But they're still normal faults. They're just a series of normal faults. Okay, so that one was a little bit more challenging, but you can see you would never get anything like this. This is a little bit too hard to see. I'd give you much better Horst and Grabens. Okay, let's go ahead and do this one again. What we have to do is, first thing, we identify the fault. Right there, you guys can see it. Okay, next thing, identify the hanging wall. The hanging wall is on this side because it's the side that's kind of on top of the fault. And then we find two rock layers. This one is easy to find. So to get it like this, which way did the hanging wall move? It moved up. This, because the hanging wall moves up, is referred to as a reverse fault. Now, to do this, what you have to do is you have to compress the rock. So the rock was moving toward each other, and then what ended up happening is the rock then got pushed up. Okay, it fractured right here, and then it got pushed up. So that is compressional forces. Okay, so you had brittle deformation with compressional forces in a reverse fault. Let's look at our next one. Our next one here is you go ahead and you identify the fault. Well, I can see that the fault is right here. Kind of goes all through there. Okay, so there's the fault system. I can easily see these two rocks right here. Now, what do we notice here? We notice that the rock is seriously on top of, so the hanging wall is clear on top of it. So again, that is a thrust fault. Okay, and so by looking at the thrust fault, you can actually say that, again, to push this rock on top, you had to have compressional forces, and then it was, of course, brittle deformation. Anytime you start talking about faults, it's always brittle deformation. And so that's how you go about determining which type of actual fault it is. And those are the things that you actually look for. Okay, so what we're going to look now is the last type of fault. And of course, this is what is called a strike-slip fault. Okay, so the first thing again we're going to do is we're going to go ahead and we're going to identify our fault, which we can see right through here. And then we look for similarities or similar bodies of rock. We can see that this rock over here and then this rock right here actually match up. So because they are offset like this, we notice that this side is moved like this side is moved like this. So automatically this right here is what is known as a strike-slip fault. Okay, now again, just because we've done it earlier, what you would do is you would kind of say, okay, I'm going to stand right here on the fault. I'm going to look to this side and I notice that it moved left. Of course, I look to this side and notice that so this is what is called a left lateral strike-slip fault. So, okay, so that's how you go about distinguishing between the different types of faults. The key things to remember is you have to identify where the fault is. The next step is to identify, did the hanging wall drop or did it go up? The third thing is based on that motion, you determine, is it a normal fault, a reverse fault? Is it a thrust fault, or did it offset, which gives us a strike-slip fault? And then finally, you can actually use these structures to tell you if it is, if it was compressional tension, tensional, or in this case, which I forgot to go over, this right here is what is called shear stress. So they're working against each other. They go in opposite directions. Okay, so that's how you go about doing that. Hopefully this video helps you out in distinguishing between the different types of faults.